Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is subsection 4.3.5, subgroups, cosets, and quotients. Now, let's take a look at this. This right here is a group. This is Z mod 6, Z. So we have 0 through 5 as representatives, and this is an addition table. Now, notice something about this addition table. Some things are colored blue. Now, notice that if we add two blues together, we get another blue. And everything in the blue is the same. It's 0, 2, and 4. And in every line, you see exactly 1, 0. In every column, you see exactly 1, 0 with the blues. So actually, what we're looking at is we're looking at a subset of the overall group. So the subset is 0, 2, and 4. That makes up a group itself. It's called a subgroup. Notice that, that it has inverses, and it's closed because you had two, like 0 and 2 or 4 together, whatever, and you get one of 0, 2, and 4 back. And since it's closed and has inverses, it must have the identity as well. And associativity is borrowed from the fact that the larger group has associativity, which means that it is definitely a subgroup. Now, if we look at multiples of 5 in the integers, that's an example of a subgroup. If you add two multiples of 5, you get another multiple of 5. If, say, take like 10, its additive inverse is negative 10, which is, again, a multiple of 5. 0 is a multiple of 5. Associativity is borrowed from Z. It is a subgroup. Other examples are Q, when you take away 0 and consider it under multiplication. So if you take 0 is the only element that does not have a multiplicative inverse. So if you take it out, we end up getting a group. Same thing with R. This is a subgroup. So what is Q? Q is all the fractions of integers. Though that makes up a subset and a subgroup of this guy over here, the reals with 0 taken out. Similarly, we can think about real numbers versus complex as being a subset. Okay. So, all right. Now, here's another idea called a coset. What is a coset? Well, if we take a subgroup of a group, so suppose this is like H is a subgroup and G is a group, and this is the operation, then we look at shifts, meaning you take all the elements of this subgroup and you kind of shift them over. A prototype example would be like what we've been seeing with the fibers of a merge. All the in like Z mod 6, even. As we go to Z mod 6, we have different fibers, and all of these fibers. So this right here, this is everything that's one more than a multiple of 6. This guy is everything n is a multiple of 6. Notice that 1 bar is a shift of 0 bar. Basically, you take all of 0 bar, everything in 0 bar, that's all the multiples of 6, and you add 1 to all of them. That gives you 1 bar. So 1 bar is a shift of 0 bar. Similarly, 2 bar is a shift of 0 bar, 3 bar is a shift, 4 bar is a shift. We're just adding. These are additive shifts. These are cosets. These are cosets of 6Z. 6Z is a subgroup of Z, and all these guys are cosets of that subgroup. So that's basically what a subgroup is. Now, sometimes this is a little notation, depending on if our operation is not commutative in our group, then this might be important because maybe we're adding on the right versus the left. So technically speaking, like let's take a look at this. G over H is technically speaking denotes the collection of cosets, left cosets, where where we're taking the subgroup H and we're adding things from G. Notice, look, GH, notice how the G happens on the left and H happens on the right. G is where you take your additive shifts from. So like you take an additive shift of H. So the collection of cosets or shifts when you're adding on the left side, that's G slash this way and then H. And the other way, it's like this. But notice G is always above the slash. G is always above the slash. But in order, this just means that you're adding on the right side. But basically, just different notations for the collections of cosets. Now, what happens when the operation actually is preserved in this merge or in this quotient? That means that H as a subgroup is behaving normally, like we're used to, like with Z mod 6 or something like that, and we call it a normal subgroup. So when the collection of cosets actually ends up being fibers of a merge that preserves an operation, then we call that subgroup a normal subgroup. We'll be seeing a little bit more of these as we keep going. But for instance, actually, this for any commutative group, actually every subgroup is normal. So we're going to see examples of that not happening when we look at groups that are not commutative. But in general, like 5z is a normal subgroup because if you take z mod 5z, it preserves addition, right? This quotient, this merge preserves addition. So it's normal, it's behaving normally. And in here as well, this also preserves addition. So it is, so this right here is it's an additive normal subgroup of this polynomial additive group. Thanks for watching.